Integration by substitution is essentially trying to make things simpler for you. If I asked you what is the integral of x cubed, then I would expect that you could tell me right away it's add 1 to the denominator, divide by, add 1 to the exponent, divide by that new exponent, add c on to the end. And really, you could, if I give you 3/2, you could tell me it's, well, add 1 to 3/2, that makes 5/2, divide by 5/2, add c, that, just to make life easy, turn over your denominator so that it looks a little bit nicer. But I would expect that you can sort of do this all day long if I give you just a variable to an exponent. I could throw a 6 in front of this and we just keep the 6. I could throw a negative 1/8 and we keep it negative 1/8, which I would then just do that 1/8, but we will multiply with negative 1/8 and simplify. But again, I'm expecting that something like this you could work through. Which is now why we think about integration by substitution. Any questions about this before I erase it? You have to speak quick because I'm taking silence as no questions. And you may have to speak up. Just simple integration. Like if I have an integral of x, let's go 7x to the 4th plus, we're not going to worry about that. So again, if I ask you to integrate this, because it's a variable to an exponent, we just have is working the power rule of derivatives backwards. If I said, if I took this away, and I said, what's the derivative of this? You would multiply and subtract 1. Well, we're going backwards. We're adding 1 and dividing. So if I take a look at this and throw it back to the integral, I'm adding 1 to my variable, and now I'm dividing by it. And the 7 just remains. So there's the big idea, basic idea of integration. And now when I look at this example here, it looks complicated, but we're going to take the same idea of the chain rule and apply those ideas here. And there's a reason why we call it integration by substitution, or the chain rule backwards. And that is step number 1, identify u. And again, just like we were doing with the chain rule, it's like, what is the function inside the function? And 90% of the time, look at what's inside the parentheses. That's the function that got put inside the function. And so my u here is 3x squared plus 6. Now my du is the derivative of 3x squared plus 6, so that's just 6x. And if you watched one of the videos before. I'm going to sort of be consistent with it. Normally, we write du dx, but it's like I'm multiplying with the dx. So du is equal to 6x times dx. Now, why am I doing all this? When I look over here at my integral, and this is red. When I'm looking at my integral, here I see u, and I can think of it as u to the 4th power. Here I have x and the dx, and here I have x and the dx. So I'm almost able to rewrite this as u to the 4th power du. But there's one little problem. This du is equal to 6 times x dx. I've got my x, I've got my dx. I don't have 6 in here. And so what I need to do is to think about, if I divide by 6, then this is x dx. And I'm going to, I know I said divide by 6, but I want to think of it as multiply by 1/6. Because what I really want to say is 1/6 du. Make it a multiplication and not a division. But now what I've got is exactly the pieces I need. I've got my 3x squared plus 6 equal to u, so I can replace it with u. I now have my x dx, and I'm going to replace x dx with 1/6 du. Now, let me pause there, because I've talked real fast. Questions? Something you want me to repeat?
If you go from, I went from 1/6 u equals x dx to
To here?
yeah, how do you place each step?
Yeah. Now maybe you can go a step farther back, just to make my thinking for you clear. So when I have these two pieces, I can see I can replace all of this with u. So I have u to the 4th power. X and dx, I can see are there. But in my derivative of u, I have this 6, which I don't have in my integral. So I'm going to remove the 6, which is simply, and what I really want to think about is, if I multiply by 1/6, then 6 times 1/6 make 1. Cancel. So I have x dx is 1/6 times du. And now my pieces all fit together. X dx is here. X dx. 3x squared plus 6, I've got. So now I can just call this u to the 4th times 1/6 du. But this 1/6 is just like a number that I could have written here. All right, sorry about that. So I have 1/6 u to the 4th du, and now I'm just like those first set of questions that I said to integrate. This becomes add 1 to 4, u to the 5th, divide by 5, multiplied by 1/6 du, goes away. We're back to indefinite integrals, so don't forget to add c. And I can just simplify this as u to the 5th over 30 plus c. Now, that's the substitution to make my life easier. Our last thing to do is, don't forget, u is 3x squared plus 6. So our final answer is 3x squared plus 6 to the power 5 over 30 plus c.